Doubt the singularity isn't here quite yet. So welcome everybody to our conference on the ethics of artificial intelligence. I'm David Chalmers, co-director of the Center for Mind, Brain, and Consciousness, who are co-director with Ned Block. Our center is co-organizing the conference with the Center for Bioethics here at NYU, which is directed by Matthew Liao. To get the conference open, I'd like to welcome to the stage Dean Thomas J. Carew, who's a distinguished neuroscientist and also the Dean of the Faculty of Arts and Sciences, to make some opening remarks. So please welcome Tom.
Makes me nervous. Whenever I was called Thomas, my mother was going to get mad at me soon thereafter. But let me just join my voice to that of Dave's and welcome you to what promises to be an extraordinary couple of days. So a warm welcome to all of you to NYU. I'm really delighted to have the opportunity to provide some very brief preliminary comments to this conference, because it considers a problem of absolutely seminal importance, which is the ethics of artificial intelligence. And these questions make contact with important issues such as privacy and bias and machine classification systems, or the safety and moral responsibility of AI-guided weapon systems, or the last is the actual agency and moral status of artificial advanced systems themselves. These are fundamental and really complicated questions, and they'll require a consideration from a variety of perspectives that will range, I'm sure, across this day and tomorrow, from those that are complementary approaches, that those are orthogonal or even contradictory approaches. That's why we have such a conference. The exploration of these issues allow us to identify and address directly some deep, significant questions. Let me just raise a few that come to mind. What are the ethical principles? What ethical principles should AI researchers follow? Are there restrictions on the ethical use of AI? What is the best way to design AI that implements and aligns with human values? Is it possible or even desirable to build moral principles into AI systems themselves? When AI causes harm or benefit, who gets the blame, who gets the credit? That makes contact with this deep question of agency from the narrative of AI. Are AI systems themselves potential objects of moral concern? And finally, what moral framework and value system is best suited to assess the impact of AI? Now, these are questions of huge importance and broad reach, and I don't think there's any better place I can imagine to address them than right here at NYU, as the questions are deeply embedded in two intellectual powerhouses of this university, philosophy on the one hand, and computer and data science on the other. In addition to those two disciplines, there are a variety of other cognate disciplines that would make contact with the issues we'll discuss, ranging from psychology to law to neuroscience. And the hallmark of serious inquiry here at NYU is a deep respect for interdisciplinary discussion. And all of us in the disciplines I have just described and many others reside in three intellectual centers here at NYU: the Center for Mind, Brain, and Consciousness, the Center for Bioethics, and the Center for Data Science. These centers are intellectual hothouses where pressing and timely concepts are considered with equal mix of the deep respect for rational argument and an abiding passion for the importance of ideas. So let me conclude. One way I was thinking this morning that one might frame today's conference and might capture the overall goal would be to allow AI to actually reflect on itself, considering the ethical and philosophical issues that lay in the path of its amazing growth, with the philosophers in the room providing a moral and ethical GPS to guide the discussions as they intersect with society. So let me end, as I began, by welcoming you all. I really want to have a special shout out to David, to Matthew Liao, and to Ned Block for getting us together for this extraordinary couple of days. Enjoy NYU.
Thanks very much, Tom, and thanks to all your support for all of the activities of our centers over the years. So I'll just start with some general remarks about the conference and then segue into introducing the first session. It's a great pleasure to have so many people here. for the conference. Since we started planning this conference about a year ago, there just seems to have been a real, we thought we'd have a little academic conference to think about the ethical issues here, but it just seems the interest in this topic has really exploded, as brought out, and all the people who have registered for this conference and seem to be interested in it, and hopefully many more are watching the live stream worldwide. And obviously there's been a huge explosion of interest in AI and its impact over the last year or two. I mean, AI seems to be in the news constantly. Over the last few months, we've seen everything from AlphaGo beating Lee Sedol in the at Go, to self-driving cars and the first fatalities arising from that technology, all getting a lot of coverage. With respect to the impact of AI, there's been a lot of attention to AI impact, with a number of institutions being set up really to focus on the impact of AI. Perhaps most recently, the partnership on AI that was announced a couple of weeks ago between a bunch of the major players in the industry working on AI, some of whom are represented here today. Just in the last few days, we've seen a couple of White House reports issued on the impact and the development of AI. President Obama was making remarks about AI and its impact just a day or two ago. Then yesterday, Bob Dylan was awarded the Nobel Prize for his conversations with IBM's Watson. Okay, that's not actually true. But things are happening, faster and faster enough. Things yesterday, today, the day before, that somebody said maybe since the rate is doubling, so maybe the singularity is due to arrive about 3 p.m. tomorrow. So there's also been a lot of conferences on a lot of gatherings thinking about the impact of AI. I mean, the White House group organized 4 or 5 of them. We've had 2 here already at NYU this year. In January, there was a great conference on the future of AI that Jan LeCun organized. And in July, there was a conference on AI Now, focusing on short-term impact of AI, that was also partly organized by NYU. So it's worth asking what distinguishes this particular conference and its focus. I mean, I think primarily the thought is that rather than focusing very broadly on the impact of AI on society and the world, this conference is distinctively focusing on ethical issues concerning artificial intelligence. This is somewhat different from the issue of AI impact, and even from the closely linked issue of AI safety. I mean, every new technology brings with it ethical worries about how to develop it and to use it safely, responsibly, justly, and in accord with our values. And AI certainly raises all those issues about safety and responsibility and so on, but also raises some really distinctive issues about the connection to ethics and to ethical reasoning. I mean, just at the level of one set of issues involves the ethical use and development of AI technology, safe, responsible, and just use of specific technologies, whether it's machine classification or autonomous vehicles or autonomous weapons, both in the short term and in the longer term. So there's certainly the right kind of ethical guidelines in order to promote safe, responsible use of the technology. But there are also some really distinctive issues arising from the fact that AI systems themselves can be thought of as decision makers in their own right, making practical decisions about what to do of the kind that might involve moral reasoning if done in human beings. Think about that as ethics within AI systems. And this is an issue which doesn't just arise in the long term, it also arises even in the short term, whether it's, say, autonomous weapons or autonomous vehicles that make practical decisions about what to do, decisions of the kind which, at least if made by a human, would involve moral considerations. So I think some kind of ethical reflection is required to think about the role for ethics within AI systems themselves, and that's going to be something which we're going to have a fair amount of focus on as the conference goes along. But I mean, there's the issues in the short term where short-term technologies need to be functioning in an ethically sensitive way. And of course, in the long term, there's the issue of making sure that our AI systems have the right kind of values, the right kind of goals, the right kind of ethical principles to promote good outcomes. In the really long term, there are issues that arise even about the moral status of AI systems themselves, deriving from the fact that these may well be conscious, intelligent agents that have moral status of their own, and that's something we'll focus on tomorrow. Okay, so that's the connection to ethics broadly. Another thing that's, I think, distinctive here is this is an academic conference rather than, say, industry or rather than springing from industry or from government. And it's organized by 3 philosophers. You might think that would make it all shambolic, but so far so good. This reflects the fact, I think, that the ethical issues about AI are both practical issues. What should our ethical guidelines be for industry and the development and use of AI? But there are also some serious theoretical issues here. What is the ethical basis for building AI systems this way rather than that way? And I think all that involves some reflection about morality and value and about fundamental ethical principles that should play into reasoning about the ethics of AI. And that's a broadly philosophical project. So here at this conference, we're really aiming to bring together philosophy, where people have thought about these ethical issues for a very long time, with AI research, where people are beginning to think about them in the specific domain of AI very hard. So you might see it as AI researchers stepping back for a moment to reflect philosophically on ethical issues in the field, while perhaps philosophers step forward to see if they can help with this project, with the expertise that they've developed in thinking about ethics over a number of years. To that end, almost every session here is going to have at least one philosopher and at least one AI researcher, along with people from other fields, law, technology, cosmology, psychology, and so on, to see what they have to contribute. So we see it as an interdisciplinary academic enterprise, but with very direct practical consequences and connections. Another issue, there's been a lot of discussion about whether we should prioritize short-term or long-term issues in thinking about AI. This is an issue we certainly got caught up in the middle of in organizing the conference. We found that there are some people who think, look, the real issues are the short-term practical issues involving the impact of AI on people's lives, and worrying about superintelligence is just speculation and distraction for now. On the other hand, we got people saying, look, the serious issues are the long-term issues, because this is going to affect the very future of humanity and of the world, and by connection to that, thinking about self-driving cars and autonomous weapons is just a triviality. Well, this conference is based on the view that it's not either or. You don't need to choose between thinking about short-term issues and long-term issues. You can think about both. Certainly, there are distinctive issues that arise for thinking about the short term, and there are distinctive issues that arise from thinking about the long term and arising from general intelligence. But there are also a lot of resonances between the two issues. And when thinking about safety and responsibility, or when thinking about morality and values in AI systems, there are many issues that arise at both the short term and the long term. So in any case, at this conference, we're aiming to really look at both the short-term issues which are arising from existing technologies and those which are coming in the next 5 or 10 years, and long-term issues which may only begin to arise as we get to artificial intelligence at the human level. And we're going to gradually move, I think, from shorter-term issues to longer-term issues over the course of the conference. But I think you'll see that the issues often arise at both levels simultaneously. And I think, we're smart enough as human beings to be able to attend to 2 different kinds of issues at once, just as it's not a choice between thinking about climate, about whether people think about climate change or whether people think about AI. It's also not a choice about whether think about short term, think about the long term. We can have people thinking about both. So that brings us then to this first session on general issues, which I see we're just in time for the start of at 10 a.m. So the first session is really devoted to general issues for thinking, in thinking about the ethics of AI at both the short term and the long term. Appropriate frameworks for thinking about the ethical issues, some background ideas that might inform us in thinking about them. And to that result, we've got, to that end, we've got a philosopher and two AI researchers presenting their perspectives on these very general issues. Our first speaker is a philosopher who'll need no introduction to you, someone who's really exemplified this model of philosophy stepping forward to see if it can actually help us come to grips with these very practical issues that are going to be facing us concerning AI in coming years. Nick Bostrom founded the Future for Humanity Institute at Oxford, which has really been a leader in the academic study of issues about the future of AI, as well as having a much broader impact on thinking about these issues in industry, in the general public, and beyond. Nick's book, Superintelligence, has been really a major leader in bringing both popular attention, academic attention, industry attention to issues, especially about the longer-term future of AI, and he's really thought about these issues in as much depth as anybody has, and I hope that's going to guide a lot of more serious attention, both at the academic level and beyond, in the years to come. Today, Nick is going to talk to us about, I've lost the title. Okay, the new title is, okay, Nick is going to talk to us about a matter which he will announce to us. Please welcome Nick Bostrom.
And there we have it. Yeah, it changed a little because I was asked also to try to say something more general about this set of issues before delving into some of the issues I'm thinking about right now. So I put in this first slide, some near issues. These are things that people like to talk about when the topic of ethics of AI comes up. So self-driving cars, people love to debate that. You have a choice between running over 3 old ladies or 2 young kindergarten kids. So what should you do? How many old ladies before you should run over the kindergarten kids? So I think, it's interesting, but maybe not the most important. So I think there's 1.2 million people dying on the roads every day, and it seems to me that from a practical point of view, the main issue there is just how can we roll out this technology sooner? How can we make progress on the engineering so that we can bring down that death toll? Algorithmic discrimination, so this is when more automated processes are used to make decisions, whether to allocate credit, whether to maybe give parole, or to do a lot of other choices, then it would be nice to be able to interrogate these and to see what are the bases upon which these judgments are made. It might be that we don't always think accuracy is the only criterion. We might think that there are certain kinds of that information that shouldn't filter in to how somebody is treated. So there's discussion about that, data ownership with privacy. Will firms use the information you give them to price discriminate against you? What are sort of our tolerance thresholds for that? Virtual vice, if virtual realities become more and more lifelike, then are there certain behavior, even if they don't harm anybody, that would nevertheless be intolerable, like really vivid, realistic games simulating rape, for example. You might think that's wrong, even if there is no actual victim there. Killer robots is a big topic, obviously, jobs. And then more sort of meta problems. So some people have complained about how unrepresentative the field of AI is, and among the people thinking about it, it's kind of very male-dominated, and it's a certain demographic. So does that shape the development of the field if there are only certain types of people who are sort of participating in building these technologies. So these are all, as David said, these are all legitimate issues, and I look forward to hearing a lot of conversation about these over the today and maybe tomorrow. But there's like an additional set, which is, well, so I should say that these are all, I think, can be kind of brought under the rubric. They are basically questions about how to live well and how our society should be organized now, given the current technological landscape. So how can we arrange, we have given this technology, how can we arrange this so that we have some decent outcomes? But there is an additional set of issues, which I guess I have tended to focus more on. So if one has some timescale, which I actually think looks more like this, there's the big part that comes kind of after this technology has reached maturity. And I want to say more about that. But even that's not exactly right to capture what I have in mind. You can kind of distinguish choices that we make that have only relatively short-term consequences. And so you get to remake the choice a little bit later. So we can kind of increase the taxes this year, and then if we don't like it, we can decrease them next year. We can change things around. So what I have in mind is not so much the kinds of ethical issues that arise far into the future. Rather, what I have in mind are ethical issues that might pertain to choices, if there are any such choices that we might make, that could have long-term consequences for where we end up, where Earth-originating intelligent civilization end up. And it's really those questions that are at the core of the work that we're trying to do at the Institute. So one of these is this AI alignment problem that I talked a lot about in the book. So in a certain class of scenarios, in the class of scenarios where you have a superintelligence becoming very, very powerful, and there has been a lot of discussion about this, if at some point you have that, able maybe to shape the future according to its preferences, then how can we ensure that the preferences that this AI will have will be ones that are aligned with what we want it to do, so that we get some good outcome? Basically, how you could control very powerful AIs. And what we really are after here is scalable control. So there are a lot of control methods that exist now and that for the most part work perfectly fine. You have the off switch, you have like some other simple mechanism, and they are completely adequate. And you can propose more, but what really would be nice would be to have some set of control methods that are scalable in the sense that they would continue to work even as the system that you're trying to control becomes more intelligent. Ideally, they should work better the smarter the system becomes. And so some of the current things that we rely on might not be scalable in this sense. The off switch, for example, if you had a sufficiently intelligent AI, a sufficiently powerful AI, it might prevent you from switching it off, or it might anticipate your action. And a reward button might be another kind of control method that works fine as long as you have control over the reward button and you can understand what the system is doing, but it might not be scalable. So one approach to this is the idea of giving the AI goals that coincide with ours, so that the smarter the AI gets, the better it is able then to achieve our goals. And that's in principle a scalable control method, but it then faces this challenge of how you can specify what we really want accurately and in such a way that it doesn't have unforeseen consequences when really carried out to its logical limit. I argued in the book I call it the orthogonality thesis, which is that there is no necessary connection between intelligence and values, that in principle you could have almost any combination. You could have a really, really smart system that is really nice or really nasty or have some arbitrary goal, just as you could have a really stupid system that is nice or nasty. And we see this even within the human population. To some extent, you have all combinations, smart and dumb people are nice and evil or whatever, but this is a much larger space. One thing I would add is a lot of this is a technical engineering challenge rather than an ethics challenge. There is still the question of what kind of goal ultimately we should try to put in there. And I'd say that it's not at all clear that we would want that to be the goal of somehow optimizing the morality of its behavior, like do the thing that is the best action to do, or the action you're most confident is the right action. Because we don't really know what the true morality is. Like, suppose it turns out that it's some kind of just desert theory, and turns out that maybe we're all a little bit rotten, so maybe we all just deserve a damn good spanking. And it's like you have the future optimized according to this maybe maximally morally correct, or some ice bucket challenge or something like that just goes on forever. I mean, who knows really what the sort of truth about all these moral. So if you think of morality as maybe some way to organize ethical intuitions in some reflective equilibrium with other things, like who knows what would come out of that. And if you really put in as this unalterable goal in a very powerful optimization process, it might not be anything that we really would want at all. So maybe morality is some kind of ingredient there, but it might not be so clear that we really, on reflection, would want this to do the morally optimal thing. So there is this, but then there is this parallel challenge. So assuming you could solve the technical challenge of how to put human intentions, human goals reliably into an arbitrarily powerful intelligence, there is still then this political question that we confront, like which goals to put in, who should decide, what is the overall set of governance structures that should guide our approach into this more AI-enabled future. And so this is an area where work is at an even earlier stage. So the control problem, I mean, a few years ago, there was almost nothing. There were like a couple of groups in the world who were thinking at all about that, and that has changed over the last couple of years, and it's really amazing to see new centers springing up and research papers are starting to get published on that. But this is at an earlier stage. This is maybe where work on the technical control problem was a few years ago. So there isn't anything very complete or thought through to present here, but I want to just talk a little bit about some sort of work in progress that I'm doing together with Carrick Flynn and Daniel Defoe. I think Daniel is in the audience here somewhere. We haven't had a chance to necessarily sync up on exactly all of these things I show on the slides, but these are some thoughts about how one might begin to think about this. So what I would like to do as a first step is to think about what are the, so suppose somebody proposed some vision for how this should be governed, some roadmap, like what are the properties that one would like such a proposal to have in order for us to think that's a good proposal, that's something we could get behind. And in particular, we can look at these sort of normativity disorder, like what are these different rubrics. We'll look at some examples within each one of these. Of types of features that it would be nice if our sort of proposal for how humanity should move forward to this would have. I suggest that a useful focus here is maybe not so much what's sort of the end state, but more we could try to evaluate paths forward that start from where we are now and then lead somewhere into the future, because one might have preferences or intuitions not just about the destination, but also about how the decisions as to how to move forward should go on, the overall shape of this. We need to combine it at some point, sooner rather than later, with considerations about feasibility. So we want some proposal that actually could work, not just something that would be nice in an ideal world. And it's important there to consider the second best option. So you might have a view about what should be the best, but you might also want to have views. You might almost want to have a vector field, as it were, with kind of views about what should happen in any different situation where you might end up. Or if you're advising somebody and there is like the best thing that they should do, but for whatever reason they are just unwilling to do that, you might still want to have a view about where on the margin, where should they go if you could just kind of push them to do a little bit more of one thing or another. And we also want to consider commitment mechanisms whereby early choices might lock in later choices. So let's just briefly go through some thoughts on this. So on the efficiency, we want to look at what is different in this context of machine superintelligence. So there are obviously all kinds of considerations that apply here just as they apply to all the other things we do, but there are perhaps certain distinctive issues or ones that have more weight in this context. So AI safety work seems like an important thing here, and getting an efficient outcome, meaning one that is kind of just increases the size of the pie available, particularly by reducing the risk externalities that could come from this. So if this transition to the machine intelligence era happens, all humans, wherever you are on Earth, even if you're sitting in a little hut in Indonesia and have had no vote or input on this, you still, if there are going to be risks, you're still going to also face those risks. So it seems that one thing one can do is to recognize an obligation there to put an extra effort on that. Timely development and rollout in terms of the enormous benefits that can come from this. There is a kind of, arguably, an urgency there, in particular insofar as we care about people who exist now, as opposed to impartially about bringing new people into existence to replace us. But if the goal is to benefit the 7 billion people right now, the clock is running out, like we are dying and suffering all kinds of ills. Avoiding global coordination failure. So there's a distinct, and I don't really have time to go into them, but there's a certain class of ways in which things could go wrong, and I think it's a large chunk of all the different ways that things could go wrong because there is a failure at the global level to coordinate. That's why we can have wars and arms races and destruction of the global commons and Malthusian outcomes and so forth. Considering this vulnerable world hypothesis, for want of a better name, you could consider this hypothesis that there is some level of technological development at which offense strongly dominates defense, in the sense that at that level of technology, it would be feasible for a small group to take some action that would lead to the destruction of the world, independently of what other people do after that action has been taken. So we don't know whether the vulnerable world hypothesis is true, but maybe it is, and then you can think about, if it is true, what are the kind of arrangements that would have been put in place so that we can maintain the world intact, even when it enters such a vulnerable phase. And so this ability to undertake some kind of stabilization of the world, if that should be necessary, some way to, if there is some really dangerous technology that just would be much more easier to use to cause destruction, then maybe there would have to be some way to prevent either the proliferation of that or to very closely monitor its use. And that seems like another important variable to consider when looking at different paths forwards. Do they allow for conditional stabilization? Are they such that if it turns out that the world is vulnerable in this sense, that the world could then be stabilized, the control could be centralized, if that should be necessary? Or is the development just such that there is no way for anybody or any group of people to kind of rein it in or steer it? Allocation, so again, we all have this risk externality. Also, there is this kind of bonanza that would have, if this goes well, the amount of wealth and prosperity unlocked is enormous. It's this giant windfall. You kind of open up not just technological maturity here on Earth, but also all the space resources that our descendants can start to colonize. Economic growth for a period of time may become extremely rapid. Robin Hanson has a recent book where he discusses the world economy doubling every month or so for a period of a couple of years. And so you could have this explosive growth in productivity, which also, I think, changes the allocational question somewhat. So it's more, if you have such a large abundance, it becomes more plausible, I think, that if you could give everybody a really superb life in great prosperity, even by just carving out sort of 1% or 0.1% of the overall resource pie, then it seems to become much more of a no-brainer that you should at least do that. Whereas right now, there are more kind of trade-offs. Like some people would have to give up significant wealth in order for everybody to have a good life, or you might worry about economic incentives if you tax people too much. But this would be a unique situation where you might argue that there should perhaps be some kind of basic allotment. And another interesting feature here is that we are currently, to a large extent, behind the veil of ignorance. Nobody knows when superintelligence will be developed, who will develop it, for what purposes. So we kind of all have a shared interest, if we could, in reaching an agreement now to some kind of equitable, reasonably equitable distribution of influence and wealth of the benefits. It's like an insurance scheme. You would rather have a certainty of getting a 7th billionth slice of this than having 1 in a 7 billionth chance of getting all of it, because there are diminishing returns to wealth and power. So you might think that could argue for some kind of continuity, that if there are pathways that don't completely reshuffle the deck and just make some random set of people the winners and some other people the losers, but instead something that was more continuous with the existing status quo distribution, that could be a desirable feature. Then we have this set of issues that concern the creation of new people or new morally relevant entities, with the possibility of mind crime, as I call them. So right now we think of our computers as just objects. You could take a hammer and smash them, and it doesn't really matter. The only question right now is, how do the computers affect us? Right now, it doesn't matter how we affect the computers, because they don't matter. But you could argue that at some point they might well start to matter. I've proposed a couple of principles that include this principle of substrate non-discrimination, so that if you had something that was functionally and mentally equivalent, it wouldn't, from a moral point of view, fundamentally matter what its substrate of implementation was, whether it was silicon in a digital computer or carbon in a human brain. If they had the same functional properties and the same mental states, that would be no more relevant than whether your skin is white or black. Another would be a principle of ontogeny non-discrimination, so that holding fixed what you are, it shouldn't matter how you were created. At least I think these are principles to consider. It might well be that we need to qualify them, but as a starting point, another would be a principle of subjective time. So if there are cases where it matters morally how long something continues for. Say, if somebody is suffering, it's worth if they suffer for 10 minutes than if they suffer for 5 minutes. And if you could prevent either 5 minutes of one person suffering or 10 minutes of somebody else's suffering, you should, other things equal, prefer to prevent the 10-minute suffering. In those cases, when you have digital minds, there are two different senses of time that can come apart, because if you run the same mind on a faster computer, its subjective rate of time will go faster, even though clock time will remain the same. So the question then arises, which of these two senses of time are morally relevant? And I suggest that it's the subjective sense of time. So if you run an upload mind twice as fast, then it kind of accumulates moral weight twice as fast as well. But these are, even if these were correct, they would only scratch the surface. There is like all kinds of exotic minds with weird preferences and strange properties that nobody has yet thought about, even what we think would be their moral status. So in addition to trying to prevent mind crime, we're seeing it as a desideratum of a path forward, that it reduces the amount of mind. And by the way, so this doesn't only arise once you have sort of human level things living in machines. It could arise a lot sooner. We think that a lot of animals have moral status. And maybe once you have AIs, say with similar capabilities as a mouse or something like that, you should start to think about whether we should accord it similar moral status as we do it. If you want to do medical experiments on a mouse, you have to go through an ethics committee, and you have to like anesthetize the mouse. And it's not so much whether you kill the mouse at the end, but it's like that it doesn't suffer needless. Anyway, so that can arise a lot sooner. And it seems like a silly thing right now, but I think it will go from silly to controversial at some point in maybe the next 15 years or so. Then we also have this ease with which you can produce more offspring or copies. So with humans, it's a slope. But here you could, in principle, instantaneously copy yourself, assuming available hardware. So you then have an immediate conflict between two moral intuitions we have, this sort of reproductive freedom. Everybody should decide for themselves how many kids they want to have, and the idea that maybe there should be some minimum welfare standard, at least for kids. But if you combine these two, then it just doesn't work, right? Because you have even one person who just likes to make more and more copies. They can sort of very quickly eat up the entire resource pool, and you have an immediate descent into Malthusian condition. Voting, similarly, if you could sort of just give yourself more votes by duplicating yourself, kind of distorts the system. So maybe you would need to move to some voting based on your wealth, or maybe have each person has a suffrage token that then gets split amongst their descendants or something like that. Process. So in addition to these kind of more outcome-based properties, we might also care about how these outcomes are decided and what happens along the trajectory. In particular, one might have intuitions favoring some sort of legitimacy that you want when whatever. Maybe you think, I don't know exactly how the future should be, but I would want it to be determined by legitimate processes. And exactly what is legitimate here can be complicated. It might not be enough to say have somebody consenting to it. I mean, suppose it were the case that a sufficiently advanced AI could persuade you into anything by sort of structuring a set of arguments and stimuli in an appropriate way, then consent might not be sufficient. And finally, we might have a discussion about some of the meta. So if there are these different desiderata that might not all be completely satisfiable, and we have to trade off different degrees of satisfaction. So how should we do that? I propose this parliamentary model where you kind of think of, suppose you have different moral theories making different claims, you can think of each moral theory as a party that gets to send delegates to this imaginary parliament of deliberation. And each theory gets to send a number of delegates proportional to the probability you give to that moral theory. And then you imagine this parliament kind of deliberating, and whatever that parliament would then decide is what you should do. And the idea here is that they can trade among one another. So if some moral theory, maybe you think it's only 30% likely, but it really cares a lot about one particular choice. Maybe that theory gets its way on that choice, and maybe it kind of defers to other theories on other choices. And you could expand this to include not just moral theories, but maybe you have self-interest or different constituencies. You can kind of, so it's a sort of, tries to be a robust way to achieve compromise solutions that allow for wins. Finally, also, in addition, it might become important what the decision theory and the epistemology is that determines the long-term future. And then one might make some proposal there that should be based on the actual decision theory that humans have, or that we would on reflection have, or something like that. So that's all that I have time for, folks. Look forward to the next 2 days. Thank you.
Okay, so now we have some time for, stay up here because we have time for a few questions. Just a little bit about how this works. We'll have 3 talks, most of which will be 20 minutes. Each of them will be followed by 10 minutes or so for a Q&A for the individual talks. After all 3 talks, we'll get all 3 speakers on stage, and there'll be a chance for a bit of interaction among the group and questions from the audience. But for now, we've got time for a few questions for Nick. We have people, John will run the mic, looking for hands for questions. There's one there. There we go.
Hi, thank you. My name is Heather. My question is, you raised several issues about government, which is very interesting to me because I used to work for the United Nations and I'm a human rights lawyer. I've noticed that as technology evolves, government also evolves. And I'd love to hear your thoughts on whether or not you think the evolution of government is anywhere near close to being able to deal with the kind of challenges that the technology is now posing. And people think of parallels with like the nuclear arms race, and was our government development in line with what we were technologically capable of?
The government is what it is. I mean, it would be nice if it improves, and I think there are a lot of exciting ideas for how you could do that. I mean, it strikes me, though, that so there are these, I know some people who are into, say, these cryptocurrencies and Ethereum, and they envisage sort of some decentralized system that nobody has. But that often the very first use case they think of is, so maybe the United States could run like this. It seems to me that there should be a very long trajectory between a cool new idea and applying it to some kind of world important system, that you would want to try it on small scales first. And then if it still looks like a good idea half a century or 2 centuries later, then maybe you would really want to like apply it to the things that matter most. I mean, it's such a big question how technology can, I think there are low-hanging fruits that, so one thing I've always thought would be cool is to have a prediction market, a well-subsidized prediction market on policy futures. So you could see the running odds of the likely consequences of adopting a certain policy. Like if you raise the tax rate 5%, will economic growth be higher or lower 5 years down the line? If you close the border to Mexico, will there be more or fewer terrorist incidents? And so you could have speculators betting on these things, and then kind of read out from that some kind of market probability estimate that could maybe discipline some of the speculations. But it is a hard thing to do. So there's this technical control problem, and there is this governance problem. Arguably they are equally important in the sense that they shape the outcome equally, but it might be a lot more important to work on the technical problem because it's just harder to have a big impact on the, even if you thought out all the answers to this kind of set of governance issues, it's just much less obvious how that would impact what actually happens. And if you come up with a really clever technical solution to the control problem, there's a good chance that it will be implemented. So in that sense, that might be less important.
Okay, Holger.
Yes, thank you. I wanted to draw you out on something that's a classical angle to this whole thing, which is that it seemed to me that the interest of a lot of the questions that you're asking is premised on the systems in question being conscious. So one of the things I wanted to ask you is whether you thought that was true, or whether you thought, no, as long as they're complex enough, it doesn't really matter whether they're conscious in the familiar sense. Of course, the question how you tell, I don't just mean the question of what consciousness is, but the question how you tell whether a certain organism or a unit is conscious is much debated, but one with no clear solution. And so I was surprised that it played virtually no role in the way you were laying out the landscape of the issues.
Well, I think the only set of issues that depends on whether the machines are conscious is mind crime, where it matters for whether we think it makes a difference morally, whether the thing in the box is conscious or not. But for the other purposes, in terms of thinking about how machines affect the human condition, I think one can abstract away from that. What's relevant are their functional attributes. And I think it's an open question how easy it is, say, to build something that is not conscious but still performs at a very high level of intelligence. We just don't know whether sort of the easiest way to achieve versatile general intelligence involves something that we would on reflection think probably is conscious, or whether the easiest way to do that is through some very different architecture that we wouldn't think is conscious. I'm very uncertain about that.
Hi. So my question is actually a little bit similar to what his question was. I was interested in your principles of substrate non-discrimination and ontogeny non-discrimination. I came to this conference thinking the ethical implications of artificial intelligence more relied upon the implementation of these systems in society. I didn't consider actually having to respect these systems as possibly being conscious or some form of human intelligence. So my question first was, how do you determine if something is a mind to be respected? And also, should there be any difference at all between, say, a human mind and a simulation of a human mind in, say, an experiment?
So you're right on the first, that for the most part, the issue is about, certainly the present issues, is about how we humans use these machines and how they affect us. I was introducing this as it's actually an issue that has been very little discussed, but that could be important. If nothing else, because of just the sheer numbers, that it is very easy in certain kinds of machine learning training and experiments to create huge numbers of these systems. So if they had some moral status, then if you have any kind of aggregative intuitions where how much something matters depends on how many people are affected or how many minds are engaged in it, that it could possibly come to dominate the sum total of say human minds that have existed through history at some point. But this is a kind of a niche issue at the moment, and I gave it some time precisely because it has been neglected. So I wasn't trying to allocate my speaking time proportionally to how much people have actually been talking about these different things.
Of the things you've mentioned, what is humanity most likely to fail at?
To fail at?
Yeah.
Well, I think the Minecraft thing is fairly likely to fail at that, because if you look at the difficulties we have in extending empathy to animals, we still have a long way to go there, I think. And animals have faces and they can squeak. But if these were invisible processes happening in a microprocessor, it would be so much harder to see that we might want to take that into account. To give a more detailed answer is hard, because you would have to sort of distinguish degrees of failing at something. The real question is maybe not what are we most likely to fail at, but where on the margin could, say, the efforts by one extra person or $1 extra most decrease the chance of failing in a way that would make a profound difference to the future. And it might be that working on something that we're probably going to succeed at, but where maybe you could reduce the risk that we will fail at it by a small fraction, might be better than working on the most likely failure point. But anyway, so that becomes a more complicated conversation.
Okay, thank you very much.
Thank you.
Okay, so our second speaker is Virginia Dignam. Virginia is a professor at the Faculty of Technology, Policy, and Management at Delft University. Her background is in AI research, and she's done a lot of important work over the years on agent-based models of organizations and the dynamic aspects of organizations and how all that plays out in an AI context. She's now leading some important grants in Europe on design and values with particular reference to AI, and she's co-chair of the European AI conference this year. Today, Virginia will be speaking about on moral decisions by autonomous systems. Please welcome Virginia Dignam.
Hi. Good morning. Thank you for your introduction. And it's a pleasure to be here and to be able to discuss and present the work we have been doing in Delft and with some other colleagues in Europe on the moral decisions by autonomous systems, but more generally on responsible AI. And see if this thing works. Just a second. Nope, no, I lost it. Yeah, okay, sorry. So our work is not so much on the long-term consequence of AI, but on the very short term and the decisions that systems are already doing now. And like Pedro Domingos said some time ago, machines are very stupid now and they're already taking a lot of decisions for us. So how can we make sure that those decisions that they are making are beneficial and understand how are we dealing with those decisions, who determines who is right and wrong, what is right and wrong, and how which decisions should the machines be taking and which decisions should we not want the machines to be taking. And moreover, what is our role as users, as owners, as developers, and as society in general on the decisions that machines can or not be taking. The work we do is basically considering, we take two directions in considering the the ethical and social implications of artificial intelligence as it integrates our lives now and changes and enters the traditional systems that we are used to deal with. We look at two different aspects. In one end, the integration of ethical decisions into the machines themselves, and on the other hand, on what we call the research integrity and our role as designers of the systems and our role in the process of designing those systems, which is where we look at the design for values approach. I will talk briefly about both aspects, starting by the ethics by design or the responsibility by design. And like I said, that is about how do ethics take a role and have a role in problem solving, on the decision making and on accountability that systems should or should not have. Taking a general approach to artificial intelligence, like David said, I have a background on autonomous systems, but most of us will agree that an artificial intelligence system will have these three aspects: adaptability or learning, interaction, and autonomy. And if we want these systems to be somehow have a sense of responsibility, of the ethical awareness of what they are doing, we contend that we should extend this traditional view of an intelligent system with a few more autonomy. We should take into account the responsibility, and any of you, like me, who is a parent, know that that's one of the main issues of educating children, is to learning them to have the autonomy and taking the responsibility for their decisions. On the accountability and being able to explain what you did and how decisions taken place in the interactions is another aspect which we should look at. And finally, on learning and adaptability, we should look at the transparency of what we're doing. So it is about the deciding, the explanation and the inspection of the systems that we have. Considering the decisions of and taking responsibility for decisions, there is a lot of work, and it has been mentioned both by David and by Nick already, on all moral dilemmas and all issues that at this moment cars should or not be driving over old ladies or fat people or young people or whatever. It's not so much my issue here, but it is a very simple and very visual and an example that people understand and can relate to very easily. So it's an example which we use as a pedagogical example, let's say. So what we want to look at is these dilemmas, not necessarily the trolley dilemma in itself, but moral decisions are per definition imply a lot of dilemma, because there is not a one right solution, and you have to decide between two less optimal solutions, and machines have to do those decisions as well. So what we have looking at is that it is not just about letting the machines deciding and learning how to take the decisions on such a moral dilemma of the trolley, who should you kill or should not kill on the cars. But it's very, very much, there are more options than this one, so we should look at different options on it. So if we take into consideration both who is taking the decision in itself and how those decisions are taken, we come up with 4 possible trolley dilemmas scenarios, of which this one is what is being discussed very much. The machine itself, internally to the machine, the decision should be made. And the machine deliberates and takes into account whatever information it has from the environment to take that decision. But we contend that there are other ways to do it. The simplest one, of course, is to go back to the traditional trolley dilemma. The humans are there, humans are in the loop, and in many cases it's the best decision for the machine to tell, I don't know, sorry, and in this case you decide, I'm not the one who is going to decide because I cannot choose between the two different situations. In this case, of course, if the human is in the loop, then we have to take into account the issue of shared awareness. How is the machine able to alert the user or the person who is going to decide to what is the situation at this moment, and now be ensuring that the user is keeping aware of the decisions and of the situations, and not just disconnect and let the machine go and do whatever it is and wake up at a certain moment and have to take a decision without having the all full information about the situation. So situation awareness and shared awareness is a very important issue here, which we can do much more than what is there already. Of course, the other one is the regulation one, is about creating the either physical or regulatory or governatory infrastructures which take the decision or make sure that there is no decision to be taken. One example I give my students very often is that if you go to the metro, there are those huge doors, metal doors, which only open when you have the ticket. So you don't have anymore to deliberate yourself whether I should buy a ticket or I should try to ride the train without paying the ticket, because the whole infrastructure doesn't allow you to get to the train without the ticket. So those kind of infrastructures, also regulatory or governance infrastructures, are also ways to deal with moral decisions, and then the decision is outside the system who is doing it. And of course, the last one is the random one, okay? We just take a decision and we'll see what happens, and we can guarantee that it's random, so I'm not to blame. I had no information whatsoever. I just did the first thing which got to me, and of course, then I'm always off the hook, let's say. Whether this is the most accountable and the most moral decision, we can discuss, but it's a way to deal with decisions by machines. So this concerning responsibility. Now, if you look at accountability, there has been quite a lot of work in either which people say that when we work with machines, you give machines, and there is a lot of work on that, that you give the machine the same kind of feeling of partner or teamwork or agency as you do to people. But in other hand, there have been quite a lot of experiments also with the trolley example, in which it shows that people expect the machine to take the more rational or the more utilitarian decision than the person. So while people expect from each other in such a trolley problem that you shouldn't take the decision of actively switch the lever to kill or not kill someone. In the case of if it's a machine which is taking the decision, people expect them more to take the decision in which more lives are saved. So it has a lot to do in this case when the machine does take a decision or by itself about how to explain and how to take that explanation at a level that the person understands, and that it's not just a very technical and very deep neural network chain of events which no one can understand, but to make those explanations in a way that people can understand. We as persons ourselves happen very often to make those decisions, the explanations we give are very often created a posteriori by creating a kind of a chain of events which are plausible for the actions that we took. Whether we want machines to use those same social heuristics as we as people are doing is something we also should look at. And as we talk about accountability, one other issue from the research that I do, which is a lot on persuasive systems, and those systems, they somehow, not at all like this, but somehow tend to have some human-like characteristics. That's another issue which is important on accountability. The more human-like the system is, and the more human-like the system pretends or aims at make you believe that it is, the more the accountability that system should take for explaining what it is doing. This image here down of the old lady and Alice is from a documentary done for the Dutch TV 1 or 2 years ago, in which they had that Alice, the robot, live with some people in an elderly home, and Alice really, people really engaged and become big friends with Alice, and they would show the pictures of their children or of their youth to Alice and engaged with Alice in a very natural way. And they didn't knew that Alice was not a real robot in the sense that it was taking decisions itself, but was a whole Wizard of Oz experiment. So this kind of dealing with the human-like and especially with the vulnerable users, it has a lot to for us to be accountable for as the way to how we want these systems to explain themselves or to be dealt with and be understood by their users. Which brings me to the transparency issue, which has a lot to do about we cannot expect the systems, and especially machine learning systems, to learn and to know it all right away at once and being fully able to take decisions from the very first beginning. As we don't expect our drivers, when they start the driving, to be fully understanding of the traffic laws and whatever, and in many countries you use those L plates to indicate, I'm just learning, and excuse me for the mistakes I might make. There is that kind of issues. We can also look at that and make it aware, give the awareness and the explanation to people that the system is just learning, is not yet a full-fledged system. Next to that, I think one of the most important issues is to look or creating a new focus on the old machine learning algorithms, which is not so much to focus on the performance to the functional abilities of that system, but to use the feedback loops also to learn some moral principles to those systems, in which guide the ways that systems will learn and will evolve from where they come from. Think, what am I doing? It seems I still have some time. Okay. And of course, a lot of the learning has to do with the data that we give these systems. The systems can become sufficient good to learn from their data, but on the other end, there is a lot of evidence and a lot of studies which show that any system which is learning based on data which is generated by us as people, as societies, will necessarily take into the learning the bias that we have ourselves. And if we don't make that explicit and we don't really assume that those issues are there, then it makes it very irresponsible, let's say, to have the systems taking decisions without that explicitly making the learning and the bias, and assuming that the bias are there. So, and another issue which I would like to look at is the ownership. So these systems are typically owned by corporations, and those corporations have their own interests as well and their own biases, which are also not explicitly put into the learning and the development of the systems, which then leads me to the other side of my talk, which is about the design for value, so about our own ethical and moral responsibility as designers, as users, as owners of these systems, and which is, of course, here in the New York University, there is a long tradition of design for values research. In Delft, we also have quite some work which we do on that. And sorry, 5 minutes, yes, I'm almost done. And it's, like I say, about the awareness of our role. And as we do that, then one of the main issues is to understand which are the values, the moral values, which are we building or we are taking into consideration in the design and in the systems that we are building. from who those values come, which of those values are important, and is it a question of that the system should follow those values, must follow those values, or could follow those values? So that's also some issues which we don't really have looked much at. In a simple project that some of my students have done, we have looked at online deliberation systems in which people, you can get like what if you want the social acceptance about a certain topic, and then we ask those same people who agree on the social acceptance of smoking or not smoking, or selling fried food in the university restaurant, all kinds of stuff on political issues. We ask them, after they have done the social acceptance of what we think it's as a democratically chose decision, we ask them to look at the moral acceptability of those decisions in terms of fairness, in terms of harm, in terms of ownership, in terms of authority, and the results get quite different. So things which we have seen that again and again also in the recent cases of referendums all over the world, that what we vote has a majority, we think that this is the best solution, is in most cases against our own principles of the same groups which vote for it, if you take their moral acceptability. So we are doing quite a lot of work in this, bringing together and aligning the moral acceptability and the social acceptance. But of course, then we get very quickly into the moral overload. We want too many things at the same time which are incompatible. We want sustainability and leading to having natural gas buses, which then are not as safe as we would like them to have. So that we want to have both. Or we want to have efficient energy use, but then those smart meters leads us to less privacy and less security for the owners of those things. So how to deal with the moral overload in these cases is also an issue which requires a lot more work than what has been done so far. Which leads me then to leading a bit to what Nick also have, the issue of governance. And there is a lot of discussion on shall we regulate first or shall we allow for all developments in all kinds of directions to go. And what comes first? Shall we first, it's easier to ask forgiveness than to ask permission. It's one of the things which you use, which you hear very often. But very much in line with what Nick says, actually those two lines should go together. It's not like we should first regulate and then develop, or first develop and then regulate. No, we should really take both paths into account at the same time and integrating them together as one. So I'm getting to the end of my talk, in which basically the issue is as we get into the issue of responsibility by artificial intelligence systems, it's not so much just the responsibility by the systems or about the systems, but actually we are the ones who are responsible. Thank you.
Okay, we have time for some questions. Yes, there.
Hi, I wanted to know if there was any thoughts about these kinds of developments in terms of education, like educating the machines. We don't raise children in school thinking, how are we going to make sure that we can have total control over them, or that they don't do what we don't want them to do, right? But I don't see any sort of educational.
Yes, we raise children to be responsible for what decisions they take, and that's kind of the claim that I would like to make. So we should we raise children to learn how to be responsible for the decisions they take. Not that we want to control them, but we want them to be responsible for what they are. And that's very much what I claim that we should learn machines to, raise machines to do. And it's not something which we should accept or expect to be automatically and at the first version of that machine that it will be fully responsible for what it does. But we should create the sandboxes or the safe environments in which the machines can learn about taking their own responsibility without being right away in the positions in which they have to take the life or death decisions.
Yep, there.
Hi, my name is Dawn. My question is, you're saying that the interface from human beings and telling the computers or the artificial intelligence what is good and what is bad in choices, maybe in medical decisions. For children, for example, you tell someone, the child, it's good or it's bad, eventually they will want to investigate the opposite of what you've told them. And how could you ensure that the artificial intelligence would not want to investigate that, even though it's been told in an algorithm that, you know, this is the good portion that you should be focusing on?
That's a very interesting question. Yes, that is a risk. I think that, like I say, if you do have some experimental sandbox environments where machines can experiment before they really are interacting in a full-fledged real-world environment, that would be the place where we could let machines experiment with what is the opposite. But of course, like I say, at the end of the day, we are the ones who are responsible. We make those machines, so if we let them explore, or we create the possibilities for machine to explore and also to explore the wrong or the bad paths, we should also take into account, probably in governance and in regulation, to deal with the consequences for who and for whom, and how to deal with the consequences of wrong decisions by machines.
Other questions? Wave your own. Yep, there.
Hi. So there, up till now, it seems as if there's two separate issues that are being discussed, namely how to make machines moral, and on the other hand, how should we treat machines morally? But shouldn't they be very closely connected, as they are with human beings? Namely, why do we behave morally? Because it gives our lives meaning. Mm-hmm. And we also expect to be treated in a moral way. So for machines, wouldn't that hold as well? Once we start treating them in a certain manner, they might also be inclined to treat us in a certain manner.
Yeah. I think that connects also to what Nick was saying about comparing machines and mice. And indeed, I don't really know where that experience comes from, but there was a few months ago some experiments going on which you showed people films of people kicking robot dogs, and how people felt outraged by the feeling that they were mistreating those robots, because you could not really just go and kick the robot, poor robot, so you really give the robot some anthropological or some feeling of agency and of being an entity in itself with feelings or with the right to be treated morally. That's indeed a very important aspect, which I think it has been very little researched so far. But definitely it is an issue to consider, and to give machines the feeling of being a moral being itself, and use that as a basis for the decisions that the machine would take in terms of treating others also morally or not.
Yep.
Hi, I'm Sasha. I have a question about, as humans, like, we've come up with a set of constructs to discourage like antisocial behavior in humans, or to punish antisocial behavior, such as, like social alienation, or like, I don't know, jail time, things like that. So should there be such a set of constructs, equivalent constructs for AI systems? And if there should be, then what would that be to discourage a behavior that is,
Yes, we
undesirable?
should definitely build into the feedback loops and reinforcement loops of the learning capabilities of machines the moral aspects. So to encourage or discourage to encourage moral behavior and discourage immoral behavior. That it's definitely something which should be taken as much into account into the feedback loops and the learning algorithms of systems, as much as at optimal identifying of the correct decision in terms of the functional aspects of it. So that's one of the things we should do. How we are going to build those moral features into the learning algorithms, I wouldn't really know myself, but I believe there are people in the room who probably have much more to say about it tomorrow, I believe, Stuart. So there are work done on that, not by me.
Thank you.
Okay, well, thank you very much.
Thank you.
Okay, well, our next speaker is someone who's very familiar to many of us here at NYU. Jan LeCun has been a pioneer in AI research for many years, since back in the 1980s, doing important research on machine learning, in particular neural networks, and has been a major force in the more recent rebranding of neural network research under the label of deep learning, which has now begun pretty well to take over the world. Jan has been at NYU since 2003 in computer science and headed up was founding director of the Center for Data Science, which started about 4 years ago here. Since 2 or 3 years ago, we've been sharing him a little bit with Facebook, where he's heading up the AI group there, and most recently has been a major player in starting the partnership on AI, about which we might, I hope, hear a little bit today. But Jan's topic today is, should we fear future AI systems? Please welcome Jan LeCun.
Thank you, David. All right. Let's see if I can make this work. All right. Okay. So yeah, I'm sure David wanted me to talk about perhaps short-term impact or short-term questions surrounding ethics of AI, but I'm actually going to talk about the long-term stuff. So should we fear future AI systems? So there's sort of various pictures of how AI is supposed to behave in science fiction, from C3PO, which basically does what you tell him, or you can turn it off if you're not happy, to HAL 9000 in 2001: A Space Odyssey, and there is some collision sometimes of those two worlds, where people who expect robots to work like C3PO get really annoyed when they work like HAL 9000. HAL 9000 is the worst garage door opener ever. Yes, indeed. So I have a terrible confession to make. I actually came to work on machine learning through philosophy. It was actually, or I should say, theory of mind, linguistics, and things like this. So there's this wonderful book that I stumbled on when I was an engineering student, undergrad in 1979 or 1980, which was a debate between Noam Chomsky and Jean Piaget, and they brought both of their teams to debate the nature-nurture questions. And I was, reading things from the side of Chomsky, not necessarily by him, but by people kind of rooting for him. And I thought it was kind of preposterous to think that intelligence could appear with very little learning. On the other hand, on the Jean Piaget side, there was an article, a transcript of a talk by Seymour Papert, who's a mathematician at MIT who had worked on the perceptron. And this is the first time I encountered the possibility of a learning machine. And so I started digging the literature from the 50s and kind of discovered the perceptron, which was an analog computer at the time. And believe it or not, the model of learning that we use today, in 95%, I would say, of all the applications of machine learning and AI that you hear about are based on more or less this very simple model of the perceptron, or things that are derived from it, essentially. So the basic idea of it is supervised learning, where if you want to teach a machine to, say, classify images of cars from planes, you collect thousands of images of cars and planes, and you run them through the machine, and whenever the machine makes a mistake, you adjust its adjustable parameters, which I symbolized here by knobs, so that the answer you get gets closer to the answer you want. So it's kind of like showing a picture book to a small child where you show a picture of an elephant, you say it's an elephant, etc., and the child, of course, after just a few examples of each object can figure out what the category is. With those supervised learning machines, you need thousands of examples of each category the first time you train them. The second time you train them, they've pretty much figured out what an object is, and you only need a few examples of each sample. But it's supervised learning, so it requires human annotation, human supervision, essentially, and it limits the power of those machines in the sense that they can only do things that for which we have a very clear input-output relationship that we can produce. So this applies to not just image recognition, but language translation, classification of topic in text, summarization, all the tasks of AI systems that you see, ranking, search, etc. So that's AI today. It's really not AI. It's supervised learning. It's glorified curve fitting, you could say. So what has changed over the last few years is not that model, but is the architecture, the internal architecture of the AI systems, which now use deep learning. So whereas the perceptron was composed of essentially a chunk that was sort of hand-designed, or classical pattern recognition system, were composed of a chunk that was hand-designed that we call a feature extractor, followed by a classifier which actually embeds the learning abilities. A deep learning system is basically a cascade or a collection of learning modules that are all trained simultaneously to perform the task. And that allows, that is qualitatively different in the sense that now the machine does not just learn to classify things, but also learns to represent things. So it learns internal representations of the world. This is, of course, inspired by biology, very mildly inspired by neuroscience, not in the details of it, just in the kind of underlying general principles, but really not in the details. So the kind of inspiration that we get here is similar to what early pioneers of aviation got inspired by birds, but of course airplanes are very different from birds, even though they use the same principle to fly. So that resulted over the last few years, the techniques that are used in AI systems, deep learning and things like that today are pretty old in their basic principle, about 30 years or so. But what has happened in the last few years is that the combination of the availability of large data sets and powerful machines has allowed us to solve new problems that really weren't solvable before. And so we can build those very large convolutional nets or recurrent nets or any one of a large collection of different architectures of neural nets and get them to recognize images, construct internal representations of images in a hierarchical manner. So there's this idea that, in fact, Piaget expresses a lot in the book I mentioned earlier that learning proceeds in stages, and you sort of learn low-level concepts on top of which you build higher-level concepts, more abstract concepts. And this idea of deep learning is very much rooted in this idea that the way we represent the world is hierarchical, with more and more abstract concepts built on top of kind of more elementary ones. In fact, the recent versions of those deep neural nets have anywhere between 50 and 150 layers. It's become, there's been a huge inflation in the number of layers in those systems. And there's also been an inflation in the size of those systems in the sense that the number of adjustable parameters that we have in those models is close to 1 billion or at least several hundred million. The amount of computation that takes place to recognize a single image, for example, is anywhere between 1 and 10 billion, sometimes even bigger. So we're getting to the point where those networks are kind of the same size as what we encounter in biology, not the human brain, we're very far from this, but sort of small brains of small animals, if you want, small mammals. And with those techniques, we can do things we can do before in terms of detecting, recognizing objects, building systems that can drive cars around, and which are based on these convolutional nets techniques I was mentioning earlier. And there's a huge industry around this now, where companies are trying to kind of get machines to drive themselves. That asks a whole host of short-term ethical questions, which I'm not going to discuss. So basically, perception is not solved, but it sort of works now. We can build perception systems that work pretty well. In some instances, have as good or better performance as the human visual system for locating, identifying objects. So here's an example of recent results for a system constructed at Facebook that can, detect and label and outline objects in images, including when they are extremely blurry or ambiguous, and detect broccoli, or even count sheep. So that's perception. Okay, we know how to do perception now. And this was a very challenging task for classical AI, because classical AI, tried to focus on sort of higher level functions of human reasoning, logic, and things like this. Without realizing that most people actually in the world have no idea how to do logic. But including people you might not want to vote for, and so it turns out logic is relatively simple to mechanize. The problem with logic is to write down the rules that are necessary for logical deduction, and it turns out most of human knowledge cannot be reduced to a number of rules. So perception, for example, is very difficult to reduce to rules, which is why it took so many decades, and it took techniques like deep learning to be able to do perception. Basically, that takes the human engineer out of the loop. With deep learning, the design of the system is very basic, and it's the data and the training that really builds the machine. And those learning algorithms are better at designing vision systems than human engineers are at doing it, which is sort of humbling for an engineer like me, but that's the reality. So what people are interested in now is using the power of those deep learning methods to enable machines to do reasoning, remember things. Turns out neural nets are kind of bad at remembering things. So you have to do things like augment them with a sort of episodic memory, similar to what the hippocampus does in the mammalian brain. And so there's quite a bit of work on this, which is leading to kind of a sub-area of AI that I think we could call differentiable programming. So it's the idea that you can build essentially a computer that has a memory and has, or call it a knowledge base perhaps, and a kind of a computation engine, if you want, that operates on this memory. And that plays the role of inference engine, if you want, in logic. But here, instead of manipulating symbols with logic, we manipulate vectors with algebra. So when we replace symbols and logic with vectors and algebra, what we get is computation that's smooth and differentiable, which means it's compatible with the learning algorithms that we use, which are essentially numerical. So there's a lot of interesting work on this, which I'm not going to go into, but to focus really on the obstacles to AI. So the state of the art is that we know how to do supervised learning. We know how to do reinforcement learning, which I talk about in a minute. But there's one piece of learning we don't know how to do. That's called unsupervised learning. And the bad news is that that's what most of human learning is about. So An AI system really is a combination of perception, predictive modeling. So predictive modeling is the ability to essentially visualize or predict what's going to happen in the world just because the world is being the world or because of our actions. So imagining what's going to happen as we take a sequence of actions is what allows us to plan ahead. And the ability to predict, to some extent, I think, is the essence of intelligence. So we need predictive models. We need systems that can predict how the world evolves, their environment, remember what happened, and is able to reason and plan in this world. And we don't really know how to do this with machines. Basically, what we're asking here is the old question, that unsolved problem in AI: how do we get machines to acquire common sense? So there is a famous set of problems in AI called Winograd schemas, and you have an example of it here. My colleague in the computer science department, Ernie Davis, has a whole list of those sentences, which are ambiguous. So if I say the trophy doesn't fit in the suitcase because it's too large, you know that the it refers to the trophy. If I say the trophy doesn't fit in the suitcase because it's too small, you know that the it refers to the suitcase now. And the only way you can lift this ambiguity for this reference, this pronoun reference, is because you know how the world works. You know what those objects are supposed to do and the geometry and all that stuff. How do we get machines to acquire this kind of stuff? We're not going to type rules into machines for that. If I say David picks up his bag and left the room, there is a lot of facts that you can infer that have to happen because you know how the world works. He probably has to stand up, extend his arm, pick up his bag, walk. It's not going to fly. It's not going to fly through the wall. It's probably going to go through the door, etc. So you know the constraints of the physical world. That's what allows you to fill in the blanks of all the missing information that can be derived from just those few words. That's common sense. And we just don't have any techniques right now that allow a machine to learn this kind of common sense. So my hypothesis is that, and this is, in my opinion, the biggest obstacle to significant progress in AI, and one of the mountains that separates us from the current state of AI, which is very primitive and general intelligence, if you want, or super intelligence, or whatever you want to call it. So there are three types of learning: reinforcement learning. So this is sort of like, training a circus animal or a pet. You wait for the animal to do the right action, and then you give a reward. And that's very inefficient in the real world if it's done in isolation. Supervised learning I talked about already. This is what we know how to do now. But unsupervised learning, which is the ability of animals and humans, and hopefully machines in the future, to learn how the world works by observation, is something we don't know how to do. So the joke I've been making for a few months is, if intelligence is a cake, the bulk of the cake is unsupervised learning, the icing on the cake is supervised learning, and the cherry on the cake is reinforcement learning. And the problem is, we know how to make the icing on the cherry, but we have no idea how to make the cake. And so I sort of sympathize with my colleagues in the physics department who are sort of in the embarrassing situation to have to tell the world, we know what about 5% of the mass of the universe is, and the rest, the 95%, we have no idea what it is. Same thing here. So let's imagine what the architecture of the future AI system will be like. And this is where questions of the design of those machines and how we can control them will emerge. So an intelligent machine will be composed of really two modules. I separated them, but they're really part of the same thing. An agent that generates actions that influence the world, and then the world gives it percepts or observations from which the agent can sort of infer the state of the world, if you want. And the agent is trying to optimize an objective. That objective is sort of an immutable module inside of it that determines its morality, if you want. So it determines what the agent lives to do. And so the goal of the agent is to basically keep itself happy, which means minimize the output of the objective over the long run. And so what it has to do is figure out what sequence of actions will produce the proper percepts in the world that will put it in the state that will make its objective minimized, which is, it will maximize its happiness, if you want. So basically what will drive the machine to do something or not do something is the design of this objective, as well as how good it is at optimizing it. and then how cooperative the world is, obviously. So what does the agent have to do to be able to act intelligently? Internal to the agent, there has to be a couple of modules that basically allow the agent to imagine or plan what a sequence of actions is going to cause in the world. Okay, so internally to the agent, there has to be some sort of world simulator that allows a model of the world that allows the agent to figure out what's going to happen when I take this action or this sequence of actions, or what's going to happen if I just watch and the world does what it wants. So it's the kind of model of the world. I think it's an essential piece of intelligence, and that's why I'm saying what I said before: the ability to predict is the essence of intelligence. Internally, there is an actor that generates action proposals that we can run through the world simulator, which is kind of the way of imagining what's going to happen when we take an action. And there has to be also a critic. This is a term that's used in the context of reinforcement learning. It's basically a module that attempts to predict what the value of the objective is going to be for a particular sequence of events. And this is where the machine can design substitute objectives for the real objective. So if the real objective is, let's imagine a situation with animals or humans where the real objective is really survive and reproduce. There are sub-objectives to that, which are, some are hardwired, like, feeding, but some are not necessarily hardwired. Like, for humans, it's nowhere hardwired that we should, go to school or make money or things like this. But a lot of people kind of build this as a substitute objective function. We again have examples, maximizing money in the political world today, but they have kind of substitute objective functions that they seem to want to optimize as a way to optimize the ultimate one. So those are kind of things that are developed on the way to learning or producing optimal behaviors. So without being too technical, there would be internal to the system, again, the world simulator running a simulation of the world, the actor producing a proposed sequence of action, and then the critic kind of figuring out, is that going to be good for me? And the better our world simulator is, the more accurate the prediction of actions we can do. So one of the big questions that we don't know how to solve with the AI system is, how do we build predictive models of the world? The rest we pretty much have a good handle on. We know how to build actors. The critic, maybe there is some difficulty, but we don't know how to build a world simulator. And the reason we don't know how to build it, let me skip ahead actually, is because the world has the bad idea of being not entirely predictable. So here is a very simple example. Let's say that we want to teach a machine to predict the state of the world in a half a second, and we're training it on very simple videos where we show it a few frames of a video, and then we stop the video and we ask it, what is the world going to look like half a second from now? A fraction of a second from now. So here are two little videos where I put a pen on the table and I let it go and it falls. And the machine maybe has been trained on thousands of those small videos and happens to predict the video at the bottom left, where the pen falls to the left and the back. So this is the prediction of a generator, essentially a model of the world, that from the past predicts the future, and perhaps for some source of random variable as well. But let's say in this particular video, the world actually disagrees and produces the one on the right, where the pen falls to the back and to the right. And so it's the prediction of the model was quantitatively wrong. The result is different, but qualitatively right in the sense that it predicted the pen was going to fall, and maybe not in the right direction, because that was essentially unpredictable given the limits of the perception of the system here. And so how do we train the machine to, in situations like this, and this is something that humans and animals deal with every day, where the prediction is fuzzy, is uncertain, and we want to train the machine we want to tell the machine, okay, you got it wrong, but really you got it right qualitatively. So essentially the possible futures are represented by this sort of ribbon here, this surface of possible futures. And the real future is one point on that ribbon, And the prediction of the system is another point on that ribbon, and we'd like to tell the machine, if you're on that ribbon, you're right. It doesn't matter that you are actually technically wrong, you're sort of right. And so that's kind of a non-formal explanation of the problem of learning predicting under uncertainty, really, which is what the sort of mathematical, practical, and algorithmic problem we have to solve to be able to do unsupervised learning. So if you asked me the question 2 years ago, how are we going to solve this problem, or 3 years ago, I would have said, yeah, there's tons of ideas, but none of them work. A lot of people have been working on this for a long time, Jeffrey Hinton and myself, Yoshua Bengio, a bunch of other people on unsupervised learning. But none of them really work that well, at least not to the extent that, to the same extent as animals and humans can learn forward models. But there's an idea that came up 2 years ago by a gentleman called Ian Goodfellow, who actually was a PhD student with Yoshua Bengio at the time, called adversarial training. I'm not going to go into the details of how this works, but basically it involves training two different learning machines, two different neural nets, against each other. So one is a predictor, and another one is an assessor, or called sometimes a discriminator, which basically tries to figure out if the prediction it's observing comes from the real world, real data, or comes from the generator. And the generator tries to fool it. It tries to generate points that look as much as possible as the real world so that the discriminator can tell the difference. And so it's this kind of adversarial training. And it's a very, very cute idea. A lot of people are experimenting with this these days for things like video prediction. Again, I can't explain exactly how it works, but people have trained those things not to do video prediction, but to do just image generation, so that the input to the system is a bunch of random vectors, and you run them through what amounts to a convolutional net backwards, which I'm not going to explain how it works, but it basically produces images. And if you train this on bedrooms, and then you run a random vector in the system and have it generate an image, it will generate the image of a bedroom. And those are non-existing bedrooms generated by the system. And they have what it takes, They have a bed, they have windows, they have dressers, they have, lighting of various kinds. You can have them generating manga characters and interpolate between them. And you can even do arithmetics. So on the left, you see an image of a man with glasses. And what you can do is compute the input to the generator that will produce this image, okay, which is a vector. You can also compute the vector that will generate a man without glasses, and the vector that will generate a woman without glasses. And if you take the first vector, subtract the second vector, add the third vector, and then generate an image, you get a woman with glasses. How amazing is that? So that means in this kind of abstract space of vectors from which you can generate images, you can do kind of relatively simple arithmetics that basically embed relationships. The man with glasses is to the man without glasses as the woman with glasses is to the woman without glasses. Essentially, that's what it means. Various versions of this. So if you are in the back and you look at those images, you might think of those images as pictures, nice pictures from various sources. If you're on the front and you look at those, you can tell that those are actually not objects. So those are images generated by one of those generative models, and they capture the kind of statistics of images without actually capturing the notion of real objects. So those things don't. So this thing has been trained on thousands of, almost millions of images actually, from various categories, about 1,000 different categories. And when you run a random vector through the system to generate an image, it generates images that look like objects but are not objects. It's sort of abstract painting, but it looks like real thing. If you train it on dogs, it generates like Salvador Dali kind of dogs, like soft dogs, So it's got the details right, but not kind of the big picture. And so that, it's because the abstraction level at which those things are generated is a little too low. It hasn't really abstracted the notion of dog, really. It has abstracted kind of the statistics of dogs, if you want. So it works also for video prediction. These are a few snippets of videos where the first 4 frames are observed, and then the last 2 frames, which are circled in red, are predicted by a video prediction system. And if you're not careful, if you train with sort of a classical algorithm that doesn't use this adversarial training, you get this very blurry prediction at the top here. So the system can do nothing but predict an average of all the possible futures, and that ends up being a blurry image that's kind of the average of all the possible things that can happen. But with this adversarial training, you get fairly sharp predictions, which may be wrong, but they look plausible. So other examples where here, it's funny because we take a photo that we take a camera that we turn around, and the system has to predict, has to basically invent what this apartment is going to look like that it's never seen before. And so, it sort of continues the bookcase and the shape of the couch and all that stuff. Yeah. So what will future AI systems be like? Okay, so this it's difficult for us humans to imagine an intelligent entity that doesn't have the drives and the failings of human nature. So as humans, we have self-preservation instinct. We have the desire of access to resources. We don't starve. Some of us, not necessarily the smartest, have desire of access to power to control other people. So that's not necessarily correlated with intelligence, by the way. So we have this instinct of associating all of those traits to intelligence. But in fact, they are, as Nick said earlier, they are orthogonal. So the kind of drives you can have and the sort of moral fiber you can have is orthogonal to your level of intelligence. You can have intelligent machines that don't have all the failings of humans. So one way to make sure that AI systems will have sort of a moral fiber, if you want, or basic drives that are aligned with human morality, essentially, is to design this objective that I was talking about earlier to be get the machine to do the right thing, but also to be immutable so that the machine cannot modify it. And that's basically the way we're built. Those basic drives, we can't really modify them. We can build on top of them, but we can't really modify them. So that would be one way of preventing sort of unsafe AI, have kind of good designs for those objectives and safeguards built into those objectives. But what can possibly go wrong? Well, we can wrongly design the objective. We can build incompetent agents. Or we can make them live in a world that's trolling them and turning them into bad robots. And that happens. In fact, that's probably something that has consequences in the short term. So there is, the famous example of the Thai dialogue bot that Microsoft deployed recently that got trolled immediately, and they had to shut down in 24 hours. So then there is the question: okay, so what if someone designs an AI system to be purposely nefarious and sort of releases it to the world, and then it becomes an AI cyber war? Basically becomes, a question of, is my AI stronger than your AI? And here is an interesting thing. I think defensive AI in an AI war will win, because if you have two AI systems with the same amount of resources, one is a general AI and therefore potentially dangerous, but one is a very, very narrow AI, and its only purpose is to destroy the first one. The second one will win. The same way maybe a bacteria or a virus can kill you. It doesn't have to be that smart, but it has to be specialized. And so there is protection against rogue AI, basically. It's specialized AI working for us. There's questions about the economic consequences of AI, which I'm going to skip. But another thing I think that's important for people in society and perhaps in this room to realize is that the emergence of human-level AI will not be an event. It'll be progressive over several decades. It will take multiple decades. People disagree on how many it will take. It's definitely not going to happen in the next 10 years. 20 years, some people ask questions. A century, perhaps. The problem is, as always in AI, we see the obstacles. We see one obstacle in front of us. In my opinion, unsupervised learning is one of them. We see this big mountain we have to climb. We don't see all the mountains behind it. And so it makes us a little optimistic, because we think that by the time we're past this first mountain, we'll have solved the problem. The history of AI has been a repetition of finding new mountains behind the one you just passed. The other thing is that no entity in the world, no lab, no company is significantly ahead of any other. You know, in certain areas, maybe one can produce something 3 months before another, but it's immediately reproduced. So it's not like there is some secret lab somewhere in Alaska or whatever place where some genius is building a human-destroying AI. That just can't possibly happen. It can't even possibly happen in labs like DeepMind, Google, Facebook, IBM, Microsoft, etc., because all the research is done in the open, mostly. If it's not done in the open, it becomes open really quickly, because people change companies and things like that. So it won't be kind of a secret conspiracy, if you want. And the good ideas come from academia anyway, so last question. This is my last slide. Will AI fear disconnection? So this is a theme that was pervasive in some of the questions we had here, and also in science fiction. In 2001, Space Odyssey, where HAL 9000 gets disconnected, is very scared. It kind of blocks the astronaut from going back into the spaceship because it is afraid of getting disconnected. So will AI systems be afraid of being disconnected? And I don't think so, because it's not necessary that they will have self-preservation instinct. Again, we have to build that into them for them to be worried about it. And so we can design those objective functions so that it's not a problem for them to be disconnected. The second one is, will it be morally wrong to disconnect them if they are intelligent? The way it's morally wrong to disconnect a person. And the thing is, it may not be morally wrong because we can save their memory on a hard drive and restore them whenever we want, first of all. So they're not a unique piece of thing that will disappear if we turn them off, like what happens with humans. And second, they may not care for the reason above. And so if they don't care, and if we can revive them, then it probably isn't morally wrong to turn them off if we want to. Thank you.
Okay, time for a couple of questions for Jan. Ned? Here.
Come in.
You started off scoffing at traditional AI. People don't understand logic, and but then you mentioned that toward the beginning of your talk that deep learning networks of the sort you work with don't actually do memory very well, and then you proposed a memory module. Doesn't that suggest that there might be a room for traditional AI somewhere in the middle between a deep learning network for perception and a deep learning network for action? So I just wonder if you could speak to that.
Right. So it was not my intention to scoff at traditional AI, because I think it has it plays an important role. I think if there is something that's wrong with it is the fact that the form in which it's formulated in terms of logic and symbols makes it very difficult to be compatible with learning, or at least the learning techniques that we understand today, which are based on gradients and numerical optimization and things like this, which are very non-discrete. So logic is discrete, and the kind of machine we know how to train are kind of continuous, if you want. And so I think the ideal combination between the two, which is what those memory networks and differentiable computation systems are, is basically how can we implement the type of operations that classical AI systems with knowledge bases and rules can do, but make them differentiable so that they can be compatible with deep learning and we can train them to do complex operations. So I'm agreeing to the implied suggestion you were making, I think.
Excellent talk. So part of intelligence is being able to describe things. And you know me, I come from machine learning. Prediction is our bread and butter, but part of intelligence is description, being able to describe or explain things. Where does that fit within your worldview of AI?
So I think that's part of human intelligence. So what's one essential characteristic of humans as social animals is language. But a lot of animals are pretty smart and can't really describe things very well. At least we don't have the feeling that they can. Maybe they can. Right. So Okay, so there are two things there, right? I mean, certainly some animals are trained. A lot of mammals, in particular, are get a lot of input from their parents to learn to survive. Some animals don't. So octopus are pretty smart, and the mother dies when the babies are born, and so they never train. They're not social animals, and they're pretty smart. They can solve problems. They can open jars to get crabs out of them, and so there are different forms of intelligence. Some that require interaction with peers, some that may not, just interaction with the world, and the necessity for explanation or description is something that comes with language and social animals, but there is plenty of animals also who are very smart and not particularly social, like orangutans. So I think, again, it's one of those examples where we think the human characteristics are necessary for intelligence, but really they aren't. Language is not necessary for intelligence, perhaps. I mean, that's a very controversial statement in this room. Maybe I should have brought a...
Okay, let's get one more from Stuart, and while that's going on, let's get Nick and Virginia up on stage.
Okay, so actually I have two questions. So one is, we're training all these recognition networks to recognize sheep, cars, Bugattis. Those are discrete things. If we're hoping that these deep learning networks will sort of grow into a whole agent, why, and they can't handle discrete, classical logical concepts and objects, then that just seems like a complete mismatch. The second question is on this issue of self-preservation. You see, we don't have to build self-preservation into the robot, but the robot, if it's halfway intelligent, knows that it can't, for example, fetch the coffee if it's dead. So we don't have to build self-preservation in. If it's going to fetch the coffee and there's a big hole in the floor, it will go around the hole so it doesn't fall into it. So it will, for all practical purposes, have a self-preservation instinct. If someone tries to switch it off and it has the goal of fetching the coffee, it will prevent the person from switching it off.
Yeah, but what it won't have is this huge surge of adrenaline when it feels threatened.
But it doesn't matter it doesn't matter, right? What matters is, what does it do?
Well,
it doesn't. I don't care whether it feels threatened or whether it worries about death. What I care about is, does it prevent me from switching it off? Does it mow down pedestrians who get in the way of between it and the coffee? Those are things that matter.
So I guess, that's a very important question, and it's essentially embedded in this the question of how you design this objective, right? So in the objective, there are very kind of low-level primary objectives like, build paper clips or whatever. But we can have other terms in the objective function that says, don't turn the whole universe into paper clips. Like, limit the amount of resources you use. Golden rule, like objectives in them. So relatively simple things that can be implemented that will kind of make them safe. But it's all a question of how do we design this objective. I don't think those are like fundamental questions of, oh my God, things will go bad if, by default. It's hard enough to build a machine that does anything. So, like building a machine that is going to destroy humanity by accident, I find that as an engineer, I find that extremely unlikely. But it all comes down to designing those objective functions. So the way you do this is, you build a machine with the objective function, you test it thoroughly without actually giving it real power, right? And you have all kinds of safeguards if you're really scared about it. That's the way we build airplanes. That's the way we build just about anything that we use. Power stations. Occasionally. It's happened twice.
Okay, thank you very much. Okay, now we've just got time for a brief panel discussion. Might first see if any of the speakers have questions for each other.
I have a question for Ian. I liked a lot your idea of the... I should put this thing on somewhere?
It's on, I think. But
it's on? Okay. Sure. I like your idea of designing the objectives to representing the morals or the ethics of the machines. But typically, ethical principles are very abstract, and machines are trained for very practical, functional things, and there is a whole link between discrimination or privacy.
Can you speak into the microphone?
Sorry. there is a lot of a big distance between the concept of privacy or the concept of discrimination or the concept of safety and the very practical functions that the systems are built on. How you would propose to bridge that distance?
Yeah, I mean, certainly it's not a solved engineering problem. There's no recipe of how you design those objective functions. And presumably, you can imagine the Asimov 3 laws of robotics could be kind of an example of those objective functions, but I never like them because they're not operational. They're not something you can sort of reduce to an objective that a machine can optimize. So you have to find substitutes of that achieve the same goal, but at the same time are easier to kind of implement, if you want. Now, for the question of, which is kind of a more short-term ethical question about AI and machine learning, which is the issue of bias, that's not a question necessarily of designing the objective function of the machine. It's more of a question of what's the appropriate data to train it on. So a learning machine will reflect the biases that are present in the training data that has been used to train it. And we've seen examples of some small companies that are not very experienced with the process of doing this, making very stupid mistakes in training AI systems with reflect the biases in their data, and predicting that crime recidivists. There's some systems like this that some cities have bought to predict the rate of recidivism for particular people, and they're biased against people with dark skin. And so there are mistakes like this that people shouldn't make. So one of the goals of the partnership on AI that David was alluding to earlier, some of the other founding members are in the room here, Francesca from IBM. One of the purposes of this partnership for AI is to define perhaps guidelines and ethical guidelines of how you build AI systems so that they're not systematically biased, they don't reflect the worst aspects of society.
Okay, time for some questions for the group. Okay, there's one there. Go ahead. Yep, Adam.
100,000 years ago, there was a conference of Neanderthal-like creatures, and it was called the Ethics of Modern Human Intelligence. And they were very worried about being outcompeted by humans, and they raised all sorts of concerns. But now when we look back, maybe they really ought to have been outcompeted, and maybe it was a good thing. So when we worry about the future of artificial intelligence, what do you think about the possibility, or the depressing possibility, that we ought to start preparing ourselves for dinner in the distant future? Because if we're worried about multiple emulations, maybe they ought to have more votes than us. Is that possible that, what's ethical with respect to artificial intelligence when it's sufficiently smart is just a question we ought to ask it?
Well, there's room between the claim that we have reached the maximum of what is valuable and the claim that whatever happens is valuable, or whatever is the most intelligent is valuable. It might be that there's a huge space of possible minds, possible modes of being, possible types of lives and experiences, and that with our human wetware, we can explore a tiny corner of that vast space of possibilities. And in this much larger space, there might be some that are more valuable and a lot that are less valuable. And what we then would have reason to do is to try to find a trajectory that eventually leads to one of the more valuable regions. It doesn't mean that just because something is smarter than us, therefore it would be a good thing if it took over. You could have, I think, a superintelligence who's, to take the classic example in this domain, whose only goal is to make paperclips. So you have a paperclip maximizer, and it's very, very good at it, and it produces a world which is full of paperclips and nothing else except machinery to make more paperclips. By the metric of intelligence, it would be far superior to us. It might have the brain the size of a planet, and yet in terms of plausible accounts for what has value, it would be inferior to us. It might not even have any internal mental life. The question remains, even if you think that there could be ways of existing that would be more valuable than our present ones, we still have to put in work to ensure that we reach those. And I think, to me, a plausible account would be that the future is very big, that there's this enormous Petri dish out there, that we could have space both for fantastic continuations of the 7 billion people who happen to live now, and also for all kinds of new exotic super beings that we should first make sure we satisfy all legitimate, easily resource-satiable preferences. If we can do that with a small fraction of the total, and then we can have a discussion as to how we use the rest of it, what additional things could be built.
So the interaction between two intelligent entities with different capabilities is something we're actually quite familiar with already. First of all, inside of our own brains, right? So we have, or let's say, our reptilian brain that basically, has all those kind of low-level drives that makes us feed and etc. And then the cortex on top of it that essentially is subservient to it, even though it builds on top of it, is subservient to it. And so you can imagine that AI system would be kind of a an exocortex, if you want, that is subservient to our brains, but extends its intelligence the same way our cortex extends the intelligence of a reptilian brain. So Gary Marcus, is Gary here? He's not here. Oh, here, okay. So, it has this little book. We disagree on many things, he and I, but it has this nice little book called Kludge where, he described this example of, you're in front of a piece of chocolate cake and your reptilian brain says, go for the calories, and your, frontal cortex, which can do long-term prediction, says, wait a minute, this is actually not good for you in the long term, so you shouldn't go for it. And sometimes your reptilian brain wins. So I think it would be kind of the same thing in our relationship to AI systems. They will probably do a much better job at doing world prediction. Right now they're terrible, but eventually they might be good at it. So they might do a good job at predicting what's going to happen next, and that will allow us to make better predictions. But in the end, hopefully we'll be in control. It's not very different from the way we use computers today, right? We have large supercomputers doing weather prediction, and they are used as a world model, as a world predictor, as a world model, from which we can make decisions. So I don't think it would be qualitatively different from the interaction we have today. Also, I don't know about you, but as a manager of an industry research lab, I'm very used to interacting with people who are way smarter than me, and I'm their boss, right? So.
Thank you all. This question's for Yanwen. It can be open to the other two speakers. I was just thinking of your predictions in the face of uncertainty and the kind of prediction ribbon in the graph, and then I was thinking about the video and imagery predictors that you showed, and I was just wondering with regards to, say, evidence in courts in the very applied case of criminal justice. At what point would you be comfortable with that being used as an application of evidence in terms of predictions of facial models when it comes to CCTV footage and et cetera?
Right. So, there's a lot of different questions there. So, certainly there are pattern recognition, vision, AI systems today that can be used for, forensic purposes, how they'll be accepted as evidence in court, I have no idea. I'm not a lawyer and I'm really not a specialist of those questions. But perhaps the same way DNA evidence is, which is kind of statistical in nature, is also accepted, or photographic evidence, which has diminishing value now that we can kind of tweak photos and stuff like that. In terms of the ability to predict, basically what forensics is about is retrodict. You observe a state of the world, and you have to deduce a sequence of actions that led to the state of the world, essentially, right? You get to a crime scene, and you have to figure out what happened. So it's retrodiction, not prediction. But it's the same problem. It's really very much a very similar kind of problem. Will machine help us in this? Not anytime soon.
Hey, question for Jan, probably, so popular today. So if the machines, if we have an intelligent machine and its primary leash is a reinforcement to specific trainers, wouldn't the easiest way to get that reinforcement to be to put a gun to the head and force the positive signal?
So I'm not sure I understand the question.
Yes, so you suggested a mechanism for control for an intelligent machine is to assign specific trainers that the machine will crave positive feedback from. That was in one of your slides. So my question is, wouldn't the easiest way to get the positive feedback or to get them to push the button would be to put a gun to their head?
Well, I mean, one of the statements I made is that I thought reinforcement learning was actually a relatively minor way of training machines. It's a relatively minor way of training humans as well. So there's very little that we learn as humans that is conditioned by reward and punishment. Most of what we learn is, the vast majority of our knowledge is through this, possibly, it's a hypothesis, of course, there's no proof of this, but it's through this prediction and sort of modeling the world, which is task independent. And then on top of this, you learn a task, perhaps using reinforcement or supervised learning, and that if you have the proper representation of the world that has been built through unsupervised learning, then learning those tasks is very quick and requires just a few examples. So this is what is surprising today. That's what creates the difference between the amount of samples that are necessary to train a supervised system today, which is thousands, whereas you show 3 pictures of an elephant to a child, and the child has figured out what an elephant is. So it's because there's a vast amount of knowledge that the child can build on top of. It already has good representation of the visual world. So yeah, I'm not sure I answer your question, but I see reinforcement as kind of playing a relatively minor role.
Okay, let's take one from Paul
I
quickly.
hate to return to this theme, but I continue to have the impression that the role of consciousness is being downplayed. So for instance, when you said, look, should we be morally worried about disconnecting them? Well, we could build them in such a way that they don't care about being disconnected, and then somebody rightly pointed out that it might be just part of the functioning to have a certain kind of functional instinct for self-preservation. The question is, if it has the functional instinct for self-preservation, Apple could easily design my laptop so that whenever I touch the off button, it said, ouch, don't turn me off, and so forth, and exhibited all kinds of seemingly caring about being turned off. The real notion of caring about being turned off is one that appeals to the notion of consciousness, which has been left out of the discussion. So I think all of these issues about whether we ought to have complicated moral views about how to treat systems turn on notions of consciousness which have not yet been figured out. Certainly the epistemology of saying whether a unit, especially one that's functionally quite complicated and intelligent in some sense, is conscious or not, has not been settled. And I think before we do that, we can't really address these questions in a correct way.
Well, so we have no problem going through anesthesia, which is, essentially indistinguishable from death, except it's reversible. And so, somehow, so that's the first point. Second point is, there's a lot of small animals who clearly fear being turned off, who I think most people would say are not conscious, or maybe they are. It depends on your definition of consciousness. So third of all, I don't know how to define consciousness, so that kind of makes this question very difficult for me to answer. But if I had to make a guess as to what people think of as consciousness, it's perhaps the ability to, of this prediction system I was I was talking about, to see yourself as part of the world, right? So you kind of observe yourself in your world simulator. The world simulator includes yourself, and so you have this feeling of observing yourself, from the outside. Why is that qualitatively different? I mean, why is there, some new sort of moral question about this particular effect in an intelligent machine? I'm not sure why there would be. Bottom line is basically I don't see the problem.
I think consciousness probably, as like many other aspects, there is gradations to it. There will be I agree that I don't know how to define consciousness, but there will be very many different levels of consciousness, from it making us believe that it's conscious to simulating consciousness to the full consciousness like we attribute to each other. So somewhere there in between will be the machine consciousness.
I think.
Sorry.
Hi, thanks so much. This is a follow-up on some things that Professor Dignam was saying, but I think everyone could chime in on it. It's about accountability and transparency.
Mm-hmm.
So if a machine learning algorithm has selected me as someone that the police should stop, we might think that I have a right to ask why I was selected.
Yeah.
But it also seems like the more powerful and efficient the algorithm is, the more complicated it will be, and the harder it will be for us mere humans to have really any grip on why it's making any particular decision based on 10,000 different parameters. So I was hoping you could speak a little bit to the trade-off between transparency and accountability and how powerful and intelligent these things are.
Yes, you're right. Indeed, the more complex the algorithms are, the more difficult it will be for it to be transparent. However, making them more complex and more efficient in the operations they are trained for is maybe not always the way to go. We have to make a trade-off between optimal operational function and transparent operation. And I think that trade-off is where we have to look at in designing those algorithms. And now we are mostly designing the algorithms from the operational efficiency. And that, yeah.
There has been a lot of discussion of artificial intelligence itself operating as a moral judge, as a moral system. But the more pressing question and the immediate question is, on what basis should we decide what kinds of choices and decisions to delegate to automated systems? And what safeguards or what conditions on the operation of those systems are required by moral standards that we ourselves are going to use. And I mean, I would just like to ask the panel whether they think that that issue, that this question is necessarily going to involve some attribution or design of moral judgment in the systems themselves. I don't think that that's obvious. It may be that all of the moral work will have to be done by us. And just by way of analogy, there is a much older technology of delegation of choices to a quasi-automated procedure, which has, been extremely important, and that is the legal system. And about the design of the legal system, these questions are very important. What should be the moral standards that we use in deciding to turn over to a set of largely automatically applied rules certain important decisions? And that kind of delegation has been a vital aspect of human civilization.
Yep.
Now, in the legal system, the parts of the machine that carry it out are human beings. And sometimes, at least in common law systems, they have to make moral judgments themselves. But a great deal of the legal system is just carried out automatically. And I would like to know why you think, if you do, that AI, if it is given authority to make some choices, is going to have to operate sometimes like a common law system with moral judgments being made by the machines.
I think part of that connects to an earlier question, and one distinction is whether the domain of application is the same or known to be very similar to the domain of testing. So in the limiting case, you have a set of points that you might want judgments over, and you can randomly select some and see how the algorithm works on those. And then you can statistically have guarantees that with a certain likelihood, it will operate within the wider domain from which you randomly sample. And there you might just want accuracy from the algorithm, and you can have fairly strong guarantees that it will behave as you intended. But if you intend to apply it outside the domain in which you can test its performance, then you need to have some understanding of how the system works in order to be able to guess how it will extrapolate from the cases it has seen. And if you can't have that kind of guarantee, then you would want to have the ability to revise it, to supervise it, to go in and change its decisions.
There's a funny thing, which is that in certain languages we call the law the legal code, right? And it's not by accident. It's code in the same way as a program is code. That we call a computer program code. So it's basically a set of rules that implement a combination of two things. One is in the little diagram that I showed, where you have the objective, which encodes the moral value. You give it a state of the world or a sequence of things, of actions, and it tells you whether it's good or not. And then there is the agent that tells you, produces actions that are according to this objective or not. And legal code, I think, is a combination of the two. So it's it's a way to define an objective function for people in society, to make people behave in certain ways. So it defines the objective function for people in some ways. That's why there are incentives and punishment, basically, in the legal code. So it's kind of a substitute objective function that makes it such that when people optimize this objective function, they ultimately maximize the common good, if it's designed properly. Of course, it's very difficult. But you're right, it's very similar. I mean, I see it in very, very similar terms, except legal code applies to societies, which are collections of people, whereas the objective I was talking about applies to a single entity or a single AI entity, and we have kind of a similar modules in our brain that sort of is our moral fiber, if you want.
Okay, final quick question right here.
Yeah, this is a quick question. I was just wondering, so instead of kind of prescribing these more general, objective, moral claims to a machine, is it possible that we could sort of use this system of neural networks to upload, if you will, or dump, I guess, the history of philosophy or moral theory more in general, and have the machine conclude on its own what might possibly be the best philosophical or ethical conclusion or standard to then hold other machines to, if you will?
You'll find there the same bias as in other. People don't agree as well between cultures or between the different people on the morality of many actions and on the concrete translation of moral principles into actions. So I think if you would take that line of that approach, we would find the same kind of bias in the decisions that the machines take as what we find now in bias in profiling and whatever. But it's an interesting approach to consider.
So I think there are two parts to philosophy. I mean, whatever I can see. The one is the sort of model of the world part, which is, you know, if we behave in such a way, here is what's going to happen in long term. Like, why is it, you know, good to have, I don't know, democracy or something like that, or, you know, sort of general principles that organize behavior. What would that lead to in the long term? So that's the issue of predicting what a particular type of behavior will produce. Will it be good in the long term or bad in the long term? And a lot of the issues, political issues that people disagree on, is basically differences in prediction of what's going to happen in the long term, or differences in weighting of short-term versus long-term objectives, like, you know, climate change or things like that. And so I think yeah, I guess I'm going to stop here. Let Nick speak.
Well, if there is going to be machines that surpass us in general, cognitive abilities in all domains, then I think it casts a new light on intellectual priorities. So there's a bunch of problems that we could defer to the more capable reasoners that we think might exist in the future. That would include a lot of moral reasoning, insofar as we think that there are progress that can be made by thinking about moral questions. That progress could be made better and faster and easier with these machines. So the task then becomes to isolate a subset of problems that we need to solve ourselves first, either because they are very pressing or because we need the answers to those questions in order then to be able to create this superintelligence in the right way. And all the other problems that we don't need to have solutions to between now and then, I think, have reduced urgency and can maybe be delegated to the future. And so I argue for this principle of delegation, which is that when possible, with a lot of qualifications, we could sort of defer a lot of these detailed judgments to the more efficient minds that will exist in the future. And we shouldn't beg the questions. We shouldn't sort of lock in our own possibly flawed guesses about factual matters. If we could instead leave that open to be revised and analyzed more efficiently by the better minds that we might build.
Okay, we've gone over time, so we better end it there. Go eat at one of the many fine restaurants nearby and be back here at 1:30. But let's thank all of our speakers for a great discussion.
A little dance, yeah.